Hello, everyone. Hopefully, you can hear me. I hope you've been enjoying the conference so far. I'm Akshay, and I'm going to be presenting about strategies to improve data analytics. Um, just to give you a bit of a background, I'm a solutions consultant working with SaaS software. We work with a bunch of clients in the data and platform engineering space. A bit about my background before we get started. So I'm actually a software engineer. I've been working. Initially, I used to work on the Linux kernel, working on really like low level Linux kernel development, working my way above the stack. I worked on like cloud engineering, DevOps, building APIs, and then recently been working on like data related problems. So I think like the way I look at it is I come from a more of a software engineering lens to look at data. So this is what I'm going to be sharing with you. Um, so what are some of the strategies that you can apply in your data analytics or AI use cases that you have to improve the data quality, and how do you like get the right insights that you want from it? So let's dive into it. So the way I'm going to be presenting this is that I'll just be taking one of the clients that I've been working with for the last few years. I'll just be driving through that. So the client that we've been working with is a large research publishing company based in the UK, and I've been working with them for like over the last year. So the company has underwent quite a lot of mergers and acquisitions, which has resulted in a very fragmented, not just a data landscape, but also like a systems landscape. So they have quite a lot of different systems that do similar things slightly differently. So what this has resulted in is that it's been a very good proving ground for us to see how do we improve the quality and experience from a data perspective across the organization, because this is something that they've never had before, where they can look for insights across the different systems that they have, so that whenever they build any sort of reports or machine learning use cases, they can have like a wider view across the organization. So what I'm planning to do is I just want to walk you through what was the landscape when we went into this client. How did we end up improving it? How we implemented those changes, and what are some of the practical lessons or key learnings that you can take with you and start implementing them in your organization or whatever project or problem that you're working on. So to dive into it, just the landscape before we went in, they had a bunch of different data sources. Some of them were relational, some of them were brand new event-based systems. And a lot of them were kind of doing similar things, slightly differently, like I said. So what was happening is that some of these systems were quite old, and they weren't even available in the warehouse for any sort of analytics usage. So it was a very broad spectrum, where if people wanted to work on a use case where they wanted to tie data together across these different systems, it was very hard for them to do that, because there was no way to correlate the data from one system with the others that they were trying to integrate with. So in some cases, they did have engineering teams who had transformed this data and were looking after it and had built this consolidated data set or a data product of sorts, but this wasn't the case across the other systems. So this is where whenever people started to build any sort of reports, it was very hard for them to get any sort of consistency. So the consumers, whenever they started consuming data from the warehouse, the same data could be interpreted differently by different teams. This also created any sort of like, if they have someone came, any of their stakeholders came with any sort of questions, it was very hard for them to answer with a certainty that, okay, this is definitely the right answer. Because if someone looked at one report, it would show one number, whereas if they looked at some other report, it may not show the same number. Also, some of the insights that were drawn, they could be incorrect because, like I said, a lot of guesswork was involved in transforming, for example, the raw events that came into a higher level report, and they would miss out on edge cases that would have been known by the domain teams working on those events-based systems, but not necessarily the data teams that were then drawing insights from it. So when we went in, one of the things that we started to do is, first of all, identify who were the data producers or the teams looking after the source systems itself. So we identified the data owners and started working with them to produce some sort of consistent data products or data sets in the warehouse itself, and making sure that they would start making these data sets available to us on a frequency that would make sense for all of the people who were consuming these data sets. Then once we started working with the data producers, we then started to become part of this aggregate data team, who was basically aggregating data from the different data sets that were made available from those source systems, and then building a consistent view of sorts across them. So the way we did that is we worked with the consumers to understand their use cases, and then once we started to understand that, then we basically went back to the producers, collaborated with them, and then built this aggregate data product of sorts, which the consumers could start using. So this is a very high level view of what we've done as a consulting business going in. So to dive a bit deeper into how we've done it, let's understand a few concepts around this. So to first of all understand about data products. So data products are usually like they're made up of three things broadly. So you have your inputs, which are the data sources. So these can be any sort of sources. They may be data sets that are produced in a warehouse. They may be Excel sheets. They may be APIs that are being built by teams. They are basically the inputs that you use to produce your data product. And then on the right side, you have your data product outputs. These are basically, again, like they can be the data sets that you've produced for your team. They can be an event stream. They could be a sheet, anything that the consumers can then use to create any sort of insights, reports, machine learning models, and so on. And then you have your internals. So this is where like everything under the hood goes. So this is where you may have some sort of ingestion pipeline, transformations, interpretation, and aggregation happening. So that's basically what forms the data product of sorts. So a couple of call outs over here. So one thing to remember is that so in this case, your inputs can be someone else's outputs. And similarly, the outputs that you're producing can be someone else's data sources. So the reason I'm calling this out is in this business, what we started to see is it started to form these networks where people were consuming data from a different team and then transforming it, making their own data product, and then someone else was using it further downstream. So it started to create this network of data products of sorts. And the reason this is important is because it goes to the next concept, where as each of those links between the data product forms this kind of a contract. Um, so data contract is basically an interface that helps your consumers and producers understand each other's expectations. So just like in software development, where you have APIs, protocols, or service contracts, data contracts are basically an interface for your data products. So it's kind of a formal agreement that producers and consumers create that will have any sort of metadata policies and expectations around your data products. And the reason it's important to have data contracts in place is that it helps you by reducing like any sort of misunderstandings that you may have between producers and consumers. And it also starts to build an environment of trust where whenever consumers are using your data products, they know that whatever is being provided is accurate and it meets their expectations. And they don't have to worry about like any of their stakeholders coming and asking questions and then like then not having answers on why it's incorrect and so on. So uh, in terms of components of data contracts, so whenever you're designing a data contract, these are the kind of things that you may want to consider. So you have uh, the inputs, which is your systems of origin. So this is where you start defining contracts with your producers. If you have they are internal, you can start having discussions with them to understand how they'll be providing data for you, and then start discussing what should be the model or schema of those data sets that they may be providing. Similarly, you want to make sure that you don't just have these discussions with your data producers or sources, but also with the people who are consuming data from your data sets or data products. So having these discussions around what are the data sets or tables or columns that they want to consume, or what should it look like, it can help you then inform what should be the schema of your data product. The other thing to also discuss is what should be the update frequency. So how often should you refresh your data? Um, Having these kind of conversations with your consumers in the beginning of uh, the data product lifecycle is very important, because that's what will also determine your implementation details. So for example, if someone comes as a consumer, says that, oh, I want data refreshed every 5 minutes, you may have to think about it in a very different way than, let's say, that someone comes and says, oh, I want it every day, where you could like go with a batch-based solution or something along those lines. And then you also need to relay these information back to your data producers or the inputs and systems of origin to see if it's even feasible to do this. And then there's also other components around metrics. So like you have your quality metrics. Basically, these are the things that would determine the quality of your data. So you can basically start enforcing validations around schemas, any sort of frequency updates. So you can actually start testing those things as well. If you have encountered any sort of limitations based on the conversations that you have with your data producers, it's also a good idea to start documenting that somewhere, so that people who are consuming your data, they are aware of those limitations, and that may inform whether it's suitable for an intended use case or not. And if there are things like sensitive data, it's also good for the consumers to know that beforehand, so that they don't put it in a place where it may not be intended, and so on. And it goes hand in hand with governance and access policies as well, where you can slightly formalize these things by having discussions around ownership, authentication, authorization, GDPR, and so on. So these are broadly the components that you want to consider when you're thinking about data contracts and building a new data product of sorts. So what are the so we started implementing data contracts, and I'm just going to share a few lessons that we've learned implementing data contracts at this research publishing company. So before we started, the way consumers would work is that they would just share a sheet of sorts with a bunch of columns that they wanted from the producers. And there wasn't really a conversation of sorts between the producers and the consumers. So they never really connected or tried to understand what exactly would these columns mean, if they actually met the needs that the consumers were looking for, and so on. So what data contracts helped us do is it helped us basically break down the silos between the producers and the consumers. So just like with DevOps, where the developers and ops came together and they started to talk to each other, data contracts helped us break silos between the producing teams and the consumers, who were then like using data for different analytics and data science use cases. The other thing that the way it helped us is because the producers basically started to understand the different ways in which consumers wanted to use their data. And similarly, the consumers started to understand a bit more on what are the intended ways in which this data should be used for. And that basically helped them understand whether data points should be used in a certain way or not for their use case. The other thing that we noticed when we started to introduce data contracts is that it needed a lot of discussion. So it kind of brought this product-focused mindset to data, where the producers really had to understand their users, their needs, and then had to think about what is the best way to design the solution that they were looking for. The way we went about this is basically we had to set up a working group of sorts where the producers, the consumers came together weekly, and they discussed about the different data components of the data contracts that we have discussed. So they discussed the schema, they basically discussed what should be the column in each of those tables that they wanted, but also the understanding behind it. So understanding how they would use that column for like machine learning use case that they were building, or like a report that they wanted to build for the senior stakeholders in the business. So that kind of brought this product thinking around data, and it basically helped create an agreement of sorts between producers and consumers. And the way we went about doing this is just by documenting all this from those working group sessions. So we basically just created a Google Sheet. But what we did here is we basically tried to create a living document of sorts where we would have discussions between the producers and consumers. And every time we discussed what was the column that they wanted, we would also capture things like constraints, how frequently it should be updated, in what ways it was being used, and then also capturing what were the different sources that it came from and how was it actually derived. What it helped us do is, by having this as a living document, anytime someone had any questions, they could just go in and comment. And we would also capture the history of those conversations. So it was very easy for us to come back to it at a later point and say that, okay, we built, the reason we've added this column this way is because of, like, here you can go and look at the history of the conversation. And it also helped us identify what are the use cases beyond the initial MVP that we built, and then like helped us expand on like the data product to build other use cases and so on. So when it comes to data contracts, how do you start? So you have your inputs, and then you start ingesting those for your transformations, and then like trying to build your data products. Um, so what I would suggest is whenever you're building your data products, try to start from the edges. So make sure that the contracts are being met on your inputs and also on your outputs. The reason it helped us is because since this was an organization that was fairly big, we really had to like start with somewhere. And so we started with the edges, basically understanding the contracts from the producers, testing them every time we ran the pipeline. And then similarly, whenever the outputs were produced, we also tested our own contracts to make sure they were meeting the needs of our consumers. So let's talk a bit more about validation then. So this is just a very simple domain model diagram in like this research publishing space, where you have a journal where people can submit papers for, which is captured as part of submissions, and then they can be part of a collection as well, which are kind of these special issues of sorts, which are part of our journal itself. So when we started implementing contracts, we started with like a very high level schema first. So we started adding some tests to make sure that the schema actually contained all the columns we needed, the data types that we were looking for. We then started adding more tests on checking like whether they met all those constraints of like being not null or like had only the values that we were looking for, uniqueness and so on. Referential integrity, etc. So what we noticed in this particular business, because these systems were older, there were cases where some of the constraints of the relationships were just not enforced in the source systems themselves. So we had quite a lot of violations in the constraints and relationships. So what I'm trying to say here is when you're about to start building your validation or your tests, try to focus on areas where you think you'll have most of your violations and focus on those areas. So for us, we focused more on what are the constraints and relationships, and we built a test suite that was more focused on those areas so that we could get a much better ROI of sorts, and we caught those errors sooner. The other thing to call out here is when we started implementing our data product, there were many cases where the contracts just failed because of violations of those contracts. And the source systems just sent us data that didn't meet those contracts. So there were cases where you will get unexpected data, and you just need to plan for it. There were cases where we went back to the source team saying that, oh, can you actually fix this data, which you said you wouldn't send us based on the data contract that you agreed. And then they came back saying, yes, we'll just add it to our backlog, and then it never just like got fixed. So you can definitely get bad data. You need to plan for it and make sure that you have conversations with your consumers around like how do you want to handle it, if you should exclude it, if you should transform it in a way that you fix it with a temporary patch of sorts. You basically need to plan for unexpected data. The other thing that came across when we discussed data contracts is there were some cases where we had just like agreed on a contract in the case like, okay, we will, in this case, there is a Boolean column here, which is currently in collection. So it's basically a Boolean column with true or false, and it is not a null column. So yes, it was very easy to satisfy this contract but then it was very hard for us actually to find out what is the correct way of interpreting this value. So this value can be true in multiple different ways, right? And all of these ways are correct. So how do we go about actually validating what is the correct way of implementing this? Um, so the way we went about this is again by having discussions with our consumers to understand uh, whatever is the way that they want us to interpret this value so that we assign the right Boolean value uh, to that column. But then the other thing we decided to do is we tried to make this, the code that we wrote, we tried to make it in a way that it could be easily readable and understandable, even to our stakeholders. And regardless of the language you're using, SQL, Python, or Spark, or whatever it is, there's always a way in which you can make it smaller, modular, and readable so that you can make the documentation as a living code itself. So always try to do that so that it's not just easier for you to remember why you've done it. You could also look at like sharing this with others who are new to the team or like who are external to then like start understanding why is it the way you build something. The other thing that you might be able to do also is like just having some comments. I know it doesn't look as cool, but just capturing the reasoning behind why you've done it, it really helps because in any sort of business, there's always like people coming and going, and these kind of things are always lost. So just by capturing comments around why you built something the way you built, it helps you come back and understand and keep that knowledge living as possible. Um, and then when we started implementing the different features for our data product, another thing that we noticed is that it was very hard for us to understand when we made a change, how it would affect the different data products that we had. Um, so there was no way of like easily understanding if I made a change, let's say that in this interpretation B, how would it affect the data sets that it was producing or any sort of downstream pipelines that we have or data products that we have. Because it's all connected, it wasn't very easy for us to identify exactly how a particular change that we were introducing would affect the entire data product. So this is where we implemented some sort of a regression or a A/B testing kind of a strategy, where whenever we made a change, we would pass it through the same inputs were passed through two branches. So we would make the change on a feature branch and then pass the inputs through the main branch and also to the feature branch. And then we had implemented these sort of deep data checks that could run along the entire pipeline wherever we pushed it. So what this helped us do is it basically helped us detect that whenever we had introduced these changes and it wouldn't produce any sort of data differences where we didn't intend to. And where it did produce data differences, we could actually go back through our pipeline and detect exactly where it happened. And it basically helped us backtrace any sort of unintended changes that we may introduce. So speaking a bit now about monitoring. So once you've introduced all these data quality checks and you've started to build your data product, how do you make sure that it is in fact reliable, and how do you make sure that it continues functioning the way you intended it to? So this is where you can start thinking about data monitoring. So this is where we brought a lot of learnings from things like site reliability engineering and applying them to our data products itself. So how do you monitor incidents? How do you come up with some sort of SLOs that you may have agreed as part of your data contracts and so on? So when it comes to data monitoring, ideally you want to have monitoring around all the different components that we had discussed for the contracts. You want to have monitoring on top of that. So having some sort of alerting on freshness so that you can, detect if any of your source systems haven't been refreshed. You don't want to run your pipeline on top of that, because then it's just going to waste any sort of compute or any other resources that you're using, right? So having monitoring on your sources to detect that they have been refreshed before you run your pipeline can help you save some of those resources. The other thing that we did is also as part of the data quality tests that we had, we also had introduced these capturing these test results as part of the pipeline itself. So whenever our pipeline ran, it also ran all the data quality checks, and we used to save those results in a database of sorts so that we could revisit it. To just start detecting if there were patterns where some failures happened frequently, then there may be something where the contract is changing with your producers, and you want to then have some conversations with them to understand why is it that these tests are failing, and you may want to change either like on the source level, or you may want to let your consumers know that okay, this is changing going forward, and so on, so that you can start capturing those changes and then understanding patterns in there. The other kind of monitoring that we also introduced is around the volume of data. So this is where what we did is basically whenever the data pipeline ran, we captured what was the volume that was, what was the data product that was like, how many rows did it produce? Was it also the same as what we expected? And did it match with the inputs that we had? So by comparing this, by comparing and capturing the volume, it helped us understand whether the data product that we had produced, was it actually complete? And if not, then we could also start having discussions with our consumers around, in case there are invalid data points, how do we handle that? Should we be excluding those? Should we be not refreshing the pipeline at all? So by capturing this volume as a metric, it also helps us understand how to handle any sort of unexpected cases. The other thing we started to do is also just capturing any sort of changes to the data contract over time. So just by capturing the data quality tests, the volume freshness alerts over time, it then helped us basically plot them over a graph. I'll show you a few examples as well, where you can just like add a simple standard deviation check of sorts, which can help you detect any sort of unexpected changes that might be happening on the source system itself, which may or may not be part of your pipeline altogether. So just a few scenarios where this actually happened. So these are real data incidents that happened as part of our data product that we introduced. So this one was around the freshness alert, which failed. So this was a case where one of our source systems, which we consume data from, they moved the location somewhere else without actually telling us that they had moved it. Since it was a big organization, they never captured who were the people who were consuming data from them. So they just didn't know whom to tell. So once they did that, our pipeline started to fail. And luckily, we had built-in alerts to check the metadata of our source system to see that it has in fact been refreshed. And then the way we implemented this is just by using Slack. So we just sent a Slack alert saying that, okay, this source hasn't been refreshed in more than 2 days. So something must be wrong because we expect it to be refreshed every day. In terms of how we implemented this is, so our tech stack was mainly built around dbt, which is a transformation tool, Airflow, which is an orchestration framework, and then we implemented these checks using something called Redata, which is a monitoring tool that sits on top of dbt. So we basically captured the freshness as a metric in Redata and then sent out Slack alerts into a channel. The other thing that we did is also this channel was made available to all our consumers. So that meant that everyone who was using our data product was aware if something was wrong. So that also helped us make sure that we continue to build trust and people are aware when something is broken. Someone is looking into it and they could follow along those conversations as well. This is another case where the schemas that we had agreed with our source systems that had failed. So again, over here, what has happened is that we captured the schema, basically whatever agreements we had with our source systems around the schema as a dbt test. So in this case, we expected the last update date to always not have null values, and we started to receive null values. It turned out that they started to send some test data into this submissions table, and they just didn't add this last update date. So when this started to happen, we went to the source, to the data producers, tried to understand what had happened. It turned out that it was just test submission, so it was very easy for us to then just go and filter out these test submissions. But having these alerts was very important because then we started to understand when the behavior of our inputs started to change. And then, so this is an example where we started to see unexpectedly high number of rows. So this was an incident that happened on one of our data producers, where they introduced a bug which basically duplicated a bunch of rows. So here you can see that the number of rows has just gone up from 4 to 5 million, 4 to 8 million, sorry. And even they didn't know that they had introduced this bug. So when we started ingesting their data, we noticed an unexpected change. So this is where implementing a very simple standard deviation check helped. So all we did is we compared the number of rows today with yesterday, and then if it exceeded a certain amount, more than 3 standard deviation, it would just alert us. And that helped us catch this. And then we went back to the producers, asked them what had happened. They found out that it was actually a bug in their system, and then they went and fixed it. So this is how you could go about improving your data products and having some sort of hygiene around this. So very high level key takeaways for you to go and think about when you're implementing your data products. And if you want to learn more, I'm happy to dive into each of those topics. I've tried to keep it fairly high level because there was a lot to cover. And yeah, I'll be happy to take any sort of questions that you may have, or if you want to dive into any of these topics deeper. And you can also reach out to me if you have any questions, scanning the barcode there. Yeah, thank you.